Welcome, scholars, to Mr. Honeycutt's math class. Today we're talking about how to analyze functions graphically as part of our mathematical modeling unit. And how this is going to work with the GoFormatives, you will watch a video that should be relatively short, and then you will practice some questions with the GoFormative to see if you understand it. So while you're watching the video, you should be taking notes, and then you're going to try to apply that information to the GoFormative questions. And then you'll watch another video, answer some more questions, watch another video, answer some more questions, and then you will do some delta math. So that's how today's going to work. Today we're talking the three tools that we're going to get. I'm going to talk about are positive and negative domains of graphs, increasing and decreasing domains of graphs, and extrema, relative and absolute maximums and minimums. This may be relatively familiar, which is fine, but it's a good place to start to kind of review and get going. So first we're starting with this positive and negative domains from a graph. And originally I was going to do this later, but the delta math really likes to make sure that you understand the difference between positive and negative domains and increasing and decreasing domains. So that's why I bumped it up a little bit. So we will revisit this as well. So first I want to start with a real world example. This is a graph of the daily temperature in Fairbanks, Alaska. The line right here is the average daily temperature. And then these little points and stuff are for the actual temperature from 2018, 2019. This is from September to March. So this is in the winter time in Alaska. So why would we care about this or whether things are positive or negative? Well, think about it. This is, near the Arctic Circle. And this right here, I showed where this is 0 degrees Celsius or 32 degrees Fahrenheit, which is freezing. Why might we care when the temperature is above freezing or below freezing? Well, that's because that's when ice melts or doesn't. So when the temperature is above freezing, that means the Arctic ice is going to be melting. And when it's below freezing, the Arctic ice isn't. So it's going to be really helpful for us to know, are we having above zero temperatures in this scenario that would tell us that the ice could be melting? Are we having below zero temperatures that would tell us when the ice is not melting and staying frozen? So just a real world example. So one of the things I want to point out here is, let's look at the notation here. This f of x is greater than 0. I actually want you to read that as that f of x is positive. Okay, just think of this as f of x is positive. All right, the greater than 0, don't even think of it as greater than 0, just think of it as positive. And then here are the values where it's above the x-axis, where it's positive. Here's some right there, and here's some more. Okay, that's when it's positive. All right, and we could also talk about f of x when it's negative or less than 0. Okay, but you need to be able to see, when you see this less than 0, you need to be able to think in your mind, wait, that means negative. Okay, which means they are below the x-axis. I don't know where that went. All right, and so that's these values, right, on the graph. So when is it above the x-axis? When is it below the x-axis? Pretty straightforward. So, and then on this, I want you to trace. I mean, if you could trace, ideally I'd give you a sheet of paper, but again, where you would trace the positives in black. Hey, look at that. It's a pretty bad trace. And the negatives in red. Isn't that exciting? Right? Now, the notations. Back to our positive domain. This is where things are going to get a little tricky. The positive, there are two ways we can use the note. We can describe these domains. We can either use interval notation or we can use set notation. Okay? So interval notation is the one that you might be a little more familiar with, especially now. Which is funny because interval notation also uses some set notation. So for this one, the black one, it's going to have two parts. It'll be from -2 to +2. Notice how this looks like a coordinate, but it's actually not. Okay, all this means is we're going from -2 to +2. Okay, and then we're going to use the union sign for the or. Okay, And then we're going to, again, go from 6 to, in this case, 14. So I guess it should be a bracket because it's still positive. Which, let's go back to that. So here at -2, it is 0. And at 2, it's 0. That means that it's actually not positive at these points, so we're going to use the parentheses, right? Same thing with 6. At 6, it's actually 0, so that means we're going to use a parentheses here. At 14, though, it's still positive. It's just we're done with the graph, so we don't know anything else about it. But it's positive, so we're using a bracket. So this x value of 14, the function is still positive. For set notation, you're going to do something similar, except you'll use an x in the middle, and you'll say, hey, x is less than 2, and x is between -2 and 2. Technically, you would read that as -2 is less than x is less than 2. I don't want you to read it like that. And if you do continue to read it like that, you're going to confuse yourselves. It's far easier to think of this as x is between -2 and 2. Think of it like that. Or less than x, less than. All right, so that x is between 6 and 14 and includes 14. So it's between 6 and 14. So x is between these or these. So it's basically, are we using the parentheses or bracket notation, or are we using the less than, greater than notation? You need to be able to know that these two things mean the same thing. That notice these just symbols all correspond to each other. Okay? And then you need to be able to jump between these fluently. That's what matters. The IB exam is going to give you either. The ACT will give you either. You just need to know that these two, even though they look slightly different, mean the same thing. Now let's look at the negative domain. This one's going to be actually a little bit simpler. Keep it right, I guess. So for the interval notation, it would be 2 to 6. Notice it's basically the opposite of the one we had before. And then in set notation, it would be that my x is between 2 and 6. That's it. So notice because we're not combining things, we don't have to do an or an and or a union or anything like that. So going back to our example here. So this was the average trend line. Okay. And I'll use for that year, it looked kind of like this. All right. Just kind of. Just a little bit. Okay. So what we can see is, here are the parts of the graph where normally the temperature is above freezing up until about a little after October. And then it stays below freezing, past March. But as we can see here, notice that it stayed above freezing quite a bit longer, almost 2 weeks longer, and it started quite a bit earlier. It's positive again. So we've got more months, more days where the temperature is above freezing, which means more days that the ice caps would be melting. So start working on the other Go formative questions to see if you can really lock this information in.